Oh, we did lose our decimal place. Okay, there, it comes back. I don't know about using this backlight. All right, folks, welcome back to another adventure in the garage. For those of you that don't know me, my name is Luke, and today I'm here to help you go through all of the test settings on your Dorman 86608 multimeter. And just right off the bat, I want to let you know, any meter that you see with the HF Transistor Port testing, if you bought it just for that and you're having trouble using it, it's not you. It's every meter that has that function does not work, and we'll go over that a little bit later in the video. Start with the opposition and then just work our way through the wheel clockwise. Go through all the different test settings, and then if you have any questions, let me know down in the comment section. I try to get back to everybody. If you found this video helpful, give me a thumbs up, and if not, give me a thumbs down. I always appreciate the feedback. Let's dive into it. We're gonna start out with the volts AC setting. That's what that little sine wave is there for. This can measure up to 600 volts AC. I personally would not touch that much voltage with this meter, but to each their own. Let's get some AC voltage going here and take some measurements. With AC, because the voltage and the current go in both directions, it doesn't matter if you do red lead to hot or black lead to hot. You can go in either direction. I do like that display, that little lightning bolts to let you know, hey, the circuit that you're working on is probably live. So that's like that. And then when you're having a manual ranger meter, this will be kind of the theme of the video. You always start big. I'll start at 600, and then if you want more resolution, you work your way down. Moving to the 200 volt setting, this means up to 200 volts. Now we have a decimal place, and we can read our voltage to the 10th. Now we have our amperage DC. Most of these lower end meters are only rated to measure DC amperage or direct current, not alternating current. In the theme and spirit of manual ranging, we'll start big and work our way small. Now, some of you are probably curious about the ports and their functionality. It's going to be really important. So this port is going to be for our voltage, ohms, and milliamps. And then this one over here is for amperage. If we're going to be measuring a larger amount of current, you'll want to switch your test lead port over. You'll only have the red lead in this port when you're on this setting and you're measuring more than 200 milliamps. When we're making a current measurement, something that we want to keep in mind is that we're always going to make our measurements in series. Right now, I have a 12 volt supply to a terminal block, and there's no direct connection to the power side or to the positive side of either one of my loads. So what I'm going to do is I'm going to use the meter as a jumper cable to complete the circuit to power my load. And then we can see we have a current measurement of 2 amps. Pretty exciting. And then I can do that too with my motor. And then back to my light bulb. Notice how both of these loads though are over 200 milliamps. So like my motor, for instance, is at 430 milliamps. So something to keep in mind, always start big, always start at your 10 amp setting if you're gonna be measuring current, because you really don't know if the load is shorted or compromised in any way, and you don't wanna blow the little tiny baby fuse that you have in your meter, because trying to replace it's probably gonna be a little bit of a nightmare. So to avoid that, do the 10 amp port, get a sense for how much your current is. If your load is turning on and it's not showing up on your meter here, then you can go ahead and swap it back over to your milliamp. So I'm gonna set us up with some smaller loads so that we can kind of get an idea. These little resistors work great for very, very small loads that we can measure. And again, we'll want these to all be in series with our circuit. So again, we'll be using the meter. It's a jumper wire, but you are all smart. You guys already know that. Make sure none of my loads are shorted out. So let's put it to the 200 milliamp setting. And then as we work our way down, you know, it's gonna be 200 milliamps, 20 milliamps, 2 milliamps. And then this funky looking U here is 200 microamps, which is kind of nice to have that setting. Okay, so that's 120 milliamps. Let's go to something smaller. Okay, now we're at 12 milliamps. So if I want to read to the hundredths, and get a more accurate measurement. Think of like, as we're working our way down to smaller and smaller numbers, we're taking like a microscope and we're zooming in to get clarity on something smaller and smaller. So if I hit this to the 20, now I can read to the hundredths and I can get a much more accurate measurement. So now I know I'm reading, okay, it's really 12.14 milliamps of current. And then we can go down to something even smaller. Now 1 milliamp is pretty small, so now we can read to the thousandths if we put it to the 2 milliamp setting. And we can see this is 1,191 microamps. And then we can put it to the microamp setting and we're getting a 1, and that 1 is telling us it's at a range. It's more than 200 microamps, so it can't read it. So you'll run into that. On other meters, it'll often be like an OL or an OC. It can mean different things depending on the context of the measurement. Here we're having a 1, and that just says like, hey, this is out of range for what I can do. Okay, let's go ahead and take a look at this transistor port HFE testing. I highly recommend, if you're gonna be working with transistors, just go ahead and bite the bullet and get something like this multifunction tester. This thing is super awesome. It auto recognizes, it gives you so much information. You can just put your transistor in there and it tells you, auto identifies NPN or PNP and labels all of your terminals for you and gives you your measurements. Something like this is great. And this is an older model too. I think they have an upgraded one that I've seen on the Amazons. Check out the link down below. We can see, if I go to my HFE setting, this isn't just this meter. All of them that have this transistor port for testing are like this. Once we get it in there, see how sensitive that is? Now, I've had people in the comments say before, oh, if you get it just right, you'll get the measurement. Think of your multimeter kind of like a calculator. If you put 8 times 8 in your calculator, you should get 64 every time, right? Same thing with your multimeter. It should be consistent in all of its measurements. You shouldn't have to second guess whether or not you have it properly all the way in the port, off to the side, whatever you got to do to try to get the right measurement. I will say this is the best one I've seen so far. Usually they're broken straight out of the box. But notice that I do have to put pressure on it to get it to measure it. So I don't waste my time with meters that have this port in here. I think it's really outdated. Just so you're all aware of how it works and what it's for. I remember the first time I saw an HFE port in a meter, I was like, what is that for? Well, it's for testing your little transistors. Okay, next is gonna be your continuity and your diode setting. Sometimes be pretty exciting. So continuity is just to let you know it's going to emit a little tone and there's going to be a threshold. Usually it's like if it's under, oh, that's not good too, that you can hear it dropping out. These leads are not good. If you do have this meter, go on Amazon and get yourself a halfway decent set of leads. I kind of compare it to like if you were to get a guitar at the music store, first thing you would do is probably change out the strings on it. It's going to be the same thing with a lower end meter. They're usually going to come with really cheap, bad leads. So leads are a wearable item anyways. So if you do work a lot with a meter or you plan on it, probably not a bad idea to have 1 or 2 sets of leads laying around. But you can hear it dropping out. That's always a bad sign. It shouldn't be like that. It should be a solid, consistent tone. And then we can go ahead and let's see what it comes back for diode readings. Sometimes these are different meter manufacturers can have different kind of readings for how they display it. Okay, this is good. So this actually does display the voltage drop across the diode, which is what we want to see from a meter. On a normal standard diode, we want to see between 500 and 800 millivolts of voltage drop, indicating that this diode's most likely good. We also always test our diodes in both directions. So for this direction, we should see a 1, indicating an open circuit. And we do. So that way we know there's no backflow. Something I always like to do too is if they do have a diode test setting, I like to see if they'll light up an LED. And this one does, just barely. I don't know if you can see that. It still doesn't look very... Okay, we're doing this in the dark. There we go. You can see it lights up the LED. It doesn't measure. Usually it'll tell you the forward voltage. Not all meters have the ability to light a white LED, but that's always good. Okay, then we can go over to resistance. Now I like to use resistors to show off the resistor settings, but any electrical load is going to have some amount of resistance in it. And I could show you that with the motor and the light bulb as well. But we can go ahead and, as always, start big. The capital M is for mega, so think of mega as million. So this is for up to 2 million ohms and down, right? And we can go ahead, and I think they start big up here. They do. Okay, so we can see that we have 1,043,000 ohms on that one. And then I'll work our way down. This one's 97,000 ohms. So if I want a more detailed reading, I can bring it down to the 200,000 ohm setting. And now I can see, okay, I have 98,300 ohms. And if I try to go below that, we'll get a 1 saying it's out of range, saying it's more than 20,000 ohms. So when you see a 1, it doesn't mean that there's not voltage or that there's not resistance. Oftentimes it could just mean that you're not on the proper setting. And that can just take some practice and some time getting used to. That's why I always start at the biggest setting and I work my way down. Let's see what we got going on here. What's this one? Okay, this one is within the range, and this one is saying, okay, there's 9,960 ohms. Keep working our way down. Okay, this is 970 ohms, so I can bring this down. Okay, this is saying there's 1,000 ohms. And then what's this one? 325 ohms is still greater than our 200 ohm setting. And then this one is 99 ohms. But we can also take a look at, measuring resistance for loads can be really handy for troubleshooting. Like if we have our light bulb here, we can see our light bulb has about 1 ohm. Our motor has about 1 ohm. So if I was troubleshooting like a component like this, like a light bulb, and I went to take a resistive measurement and I got a 1 on my meter saying out of range or open circuit, then okay, that could indicate that the light bulb is open, which means that it's broken and we need a new light bulb. So what's next on here? Okay, next we have voltage. And I'll just go through and show you kind of just what our different voltage ranges should look like. If you are using this for automotive testing, this setting, your voltage and continuity settings are probably going to be the most common settings that you're going to use on your meter. What do I have? I've got just 12 volts right now. Let's take a look and see what 12 volts looks like. Have it set to the biggest one and we'll work our way down. Okay, so this is saying that there's 11 volts present, because the resolution at 600 is not very good, right? It's expecting a big number, so this is the best estimate that it can do for what it's expecting. The proper setting for like a 12 volt battery would be our 20 volts DC setting on our meter. That would give us the most clarity with still being in range, right? But I can work my way down. Now I have to the tenths, and if I go to the 20, I should have to the hundredths. And now I can see, oh, I have 11.97. That's a big difference than just 11, right? So we always want to use to the best clarity. And then if I go to 2, we'll see a 1 pop up. It's saying 2, saying whatever you're trying to measure is greater than 2 volts DC. So let's go ahead and bring down our voltage. Let's do something kind of small. I'm outputting about 50 millivolts. It's showing 32, and then I can go to this 200 setting. It's showing 33 millivolts, so that's pretty great. And then if you're not sure, this is the hold button, so that can hold a measurement for you. So if I wanted to keep that measurement and remove my leads, and I wanted to write it down for whatever reason or show it to somebody else, you could always do that. And then it also claims to have a very intense backlight. Now this is where things get really funny with this meter, because if you turn on this backlight, oh, we did lose our decimal place. Okay, there it comes back. I don't know about using this backlight. It does some weird things to the meter. It is there, which is nice, but as you notice, like our decimal drops out completely when we have that backlight on. So something to consider, pretty much what you would expect from a Dorman meter. But there you go. There's your Dorman 86608. It's a little overpriced, but it does have a 200 micro current setting, which is kind of cool. Ring the bell, subscribe. It really helps the channel out. Check out the link down in the description. I've always got exclusive deals, and I've got a ton of other videos and all that stuff. So anyways, thank you for joining me in another adventure in the garage, and I'll catch you on the next one.